Okay, so in previous videos, we've done series circuit calculations and parallel circuit calculations, and now we're going to the next level, which is a little bit more complicated, which is combined circuits. A combined circuit is any circuit, electrical circuit, that has a combination of parallel and series. So I have two examples here. The one on the left, this one, it has these two resistors are in series, and these two resistors are in series. But this leg right here is in parallel with this leg. So it has a combination of parallel and series. And over here on this side, on this one, we have this is in parallel with this. But then you have this is in series with this. So we have a combination of parallel and series in both of these examples. In terms of doing the calculations, this one over here is a little bit simpler in terms of doing the calculations than this one. So today we're going to focus on this one over here. Okay, so I'm going to go ahead and erase this guy, or I'll move him down below, or he's out of the way. Okay, so here we go. Here we have this combined circuit here. And I'm going to use the value of, here we're going to have R1 is equal to 10 ohms, and R2 is equal to 5 ohms, and R3 we're going to say is 2 ohms, and R4 is equal to 3 ohms. And over here we have, this is the total voltage is equal to 60 volts, or a battery is 60 volts. So how do you approach this? The way you're going to approach this problem is, we always want to try to start by finding the total resistance, but this is complicated because it has series and combined circuits. And we know with series circuits, the resistance is just adding up all the resistors, right? And with parallel, so this is for series, and for parallel, we know the equation is 1 over R1 plus 1 over R2, yada, 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 okay? But for combined, you have to figure out, okay, what are we doing here? So for this particular thing, the way to approach this problem, you could be like, well, this leg here is parallel with this leg here. So, but these are in series. So if I'm looking at these in series, how would I find the total resistance of this leg? So I would do that by saying, for a series circuit, to find the total resistance in a series, and these are in series, you add up the resistors. So here, I could say, the resistance of, and I'm going to call this leg 1, because leg 1 is parallel to leg 2. So I can say the resistance of L for leg 1 is going to be, adding these up, 5 plus 10, that's going to be 15 ohms. Okay, getting a little bit squished in here. Oopsie, it's a little bit big. Let me redraw that. Okay. And then over here, I can be like, well, this, I can find the resistance, the total resistance of this leg, because these are in series, and I can be like, for this leg, the resistance of leg 2 is going to just be adding them up. So that would be 5 ohms. 3 plus 2 is 5. Okay? So now we say, okay, well, I've got, let's do a different color. I've got this leg, which is 15, and this leg. They're parallel to each other. So I can say, the total resistance, 1 over RT, because these are parallel, so we're going to use this equation, is 1 over the resistance of leg 1 plus 1 over the resistance of leg 2. So here, if we fill that in, 1 over RT is equal to 1 over 15 plus 1 over 5. So now we just solve this. We need a common denominator, which is 15. So we have 1 over 15 plus 3 over 15. That's going to be 4 over 15. So 1 over RT is equal to 4 over 15. And to get RT on top, we have to flip both sides. So we can say RT is equal to 15 over 4 ohms. So here we have RT is equal to 15 over 4 ohms. So that's our total resistance. We have the resistance of leg 1, we have the total resistance. And now, over here, we say, oh, look, anytime we have two, when we're using our equation, Ohm's law, V equals IR, anytime we have two values in any spot, we can find the third value. So here we have the total voltage and the total resistance, and we can solve for the total current. So I can say, oh, okay, VT equals IT RT. We can plug this in. We have 60 is equal to IT times RT, which is 15 over 4. Okay, I'm going to move this kind of down and out of the way. So back to here. So 60 is equal to IT times 15 over 4. Now, if I want to get the I by itself, I can multiply by the reciprocal. So 4 over 15. But whatever I do on the right side of the equation, I have to do the same thing on the left side. So now if I look at the right side of the equation, I can say, oh, there's a 4 in the denominator and the 4 in the numerator. Those cancel out. And then I have, and become 1. And now I have 15 in the numerator here and 15 in the denominators. Those cancel out. So I have 1 times 1 on top and 1 times 1 on the bottom. Okay? So now I can say, oh, 4 over 15 times 60 over 1 is equal to IT. And this is going to be times 1 over 1, but which is 1 over 1 is just 1, right? And when we have IT times 1, that's just IT. So we can just get rid of this side altogether. So we can just say that is equal to IT. Now over on the left side of the equation, how can we reduce that? Well, we know that 15, if you think about 15, if you double 15, it's 30. And if you double 30, it's 60. So 15 goes into 60 4 times. So here I can reduce this and I can be like, oh, if I divide 15 by 15, it's 1. If I divide 60 by 15, this is 4. Okay, so now I have 4 over 1 times 4 over 1 is equal to IT. So 4 times 4 is 16, and 1 times 1 is 1, excuse me. So that would become 16 over 1, or 16 amps. So now I'm going to shrink this a little bit. And right here I can say IT is equal to 16 amps. So now we have the total voltage, the total current, and the total resistance. Okay, so now let's look at this and what are we going to solve next? Because we still need to do more, right? We need to find the voltage at each resistor and the current, everything. So when I look at this, I say, what do I know? I know that leg 1 and leg 2 are parallel, and I know that in a parallel circuit, the voltage stays the same. So if I look at this, I can be like, well, I know that the voltage from here to here is going to be 60 volts. So the voltage of this leg, the voltage of leg 1 is equal to 60 volts because the voltage stays the same in the parallel circuit. And the voltage of leg 2 is equal to 60 volts. Okay, so now here, oh, look, I have two things. I have an R and a V. If I have an R and a V, I can solve for I. So now I can say the voltage of leg 1 is equal to the current of leg 1 times the resistance of leg 1. And I can plug this in. So 60 is equal to the current of leg 1 times 15. Now we can divide both sides by 15 to get the current by itself. And that would give us the current of leg 1 is equal to 60 divided by 15. And so the current of leg 1 equals 60 divided by 15 is 4 amps. So now we have the resistance, voltage, and current of this leg. Okay, that means that if we look at this, there's going to be 4 amps running through here. And we know that in a series, the current stays the same. So anywhere in this series, it's going to be the same current. So that means I1 is going to be 4 amps, and that means I2 is going to be 4 amps. Well, look at that. Now we have I and R. We have 2 things here. So that means that we can go ahead and solve for V1. V1 is equal to I1. Draw this a little bit. I1, R1. Our I1 is 4. Our R1 is 10. So that means our V1 is equal to 40 volts. It's kind of hard to see, isn't it? Let me draw it down here. V1 is equal to 40 volts. We have V1, I1, R1. And up here we can say V2 is equal to I2, R2. And that's just 5 times 4. Or excuse me, 4 times 5, which is 20 volts. Okay, so V2 is equal to 20 volts. I'm going to do a different color. Okay, that's hard to see, isn't it? Maybe I'll use yellow. Okay, so now we can do the same thing over here on this leg. We can be like, okay, we have R and V, which means we can solve for I. So the voltage of leg 2 is equal to the current of leg 2 times the resistance of leg 2. The voltage of leg 2 is 60. The current we are solving for, that's our variable, and the resistance is 5. So now if we want to get the current by itself, we divide both sides by 5, and you end up with the current of leg 2 is equal to 60 over 5. 60 divided by 5 is 12, so 12 amps. So the current of leg 2 is equal to 12 amps. So now we have the current of leg 2, the voltage of leg 2, and the resistance of leg 2. So now we know in a series circuit, the current stays the same. So that means if we look in here, and let's do a different color. And if you look at this, going up here, we have 12 amps. So that means that the current, and you know that in a series, the current stays the same everywhere. So this is 12 amps, and I4 is 12 amps. Okay? And so now we can solve for V. So here we can say V3 is I3, R3. If you multiply I3 times R3, 12 times 2, you get 24 volts. V4 is equal to I4, R4. Multiply I times R, 12 times 3, that's 36 volts. So we have successfully, gotten all the things. V4, R4, I4, R3, I3, V3. We have it on for all the resistors. So if we wanted to, we could rewrite all these things nice and neat. We could say, okay, we could say, okay, RT, IT, V, 1, I1, V2, I2, V3, I3, V4, I4, and we could just now transpose the numbers. This is 15 over 4 ohms. This is 16 amps. This one is 40 volts. This is 4 amps. This is 20 volts. This is 4 amps. This is 24 volts. This is 12 amps. This is 36 volts. And this is 12 amps. And that's all your answers. All right, I'm going to give, I'm going to stop this video and then I'm going to maybe give another one for you to work on your own.